Today we study about the micrometer screw gauge. That is how to use the micrometer screw gauge that we have to see now. The name of the experiment is use of micrometer screw gauge. Now what is micrometer screw gauge? Micrometer screw gauge. This is the name of the experiment. Here we know what is micro. Micro means is small or smallest. Smallest means what? Up to the measurement 10 to minus 6 meter. Now here meter is a name as an instrument, and here screw is the name used as the principle of this micrometer screw gauge is depends upon the principle of the screw, and here the gauge is nothing but the thickness or diameter. Now here we can say that the micrometer screw gauge is a instrument which is used to measure a smallest measurement, and the principle of this micrometer screw gauge is depends upon the principle of the screw. Now this is the micrometer screw gauge. Now today what is the aim of the experiment? The aim of the experiment is to measure the diameter of a given wire and calculate its area of cross section. And second aim is the thickness of glass plate. Now the apparatus used in this experiment is the micrometer screw gauge, wire and glass plate. Now this is the glass plate or the fiber plate, and this is the wire, which is where we have to measure the diameter of this wire. Now, and this is the micrometer screw gauge. This is the micrometer screw gauge, the instrument micrometer screw gauge. Now the diagram is given here. What are the different parts of the micrometer screw gauge that we will see now. Now it consists of the two jaws, this one and this one. One is the stud, or it is also called the fixed jaw, and another one is a screw, that is nothing but the movable jaw, and or the screw is used as a movable jaw, stud is used as a fixed jaws, and in between these two jaws we have to keep the object here. Again, it consists of the two type of the scale. One is the main scale, here we call it as a pitch scale, and another type of the scale is a circular scale. Now in a main scale there is a horizontal line, it is very horizontal hairline, and that horizontal hairline is called a reference line. It consists of the thimble. That thimble is nothing but the metal cap, which is fixed at the close end of this instrument, and it is attached to the circular scale. Again, it consists of the ratchet. Now ratchet is one of the wheel which restricts the movement of the screw either in forward or backward direction. Now whole arrangement is supported by the frame here. Now this is the frame. Now all these are the parts of the micrometer screw gauge. Now here before using any measurable instrument, we must know the least count of that instrument. Now the formula for the least count is given here. Least count is equal to pitch. What is pitch? Pitch is nothing but the distance between the two successive threads of the screw. Now here the thread. Now these are the threads of the screw. These are the threads of the screw, and the distance between the successive threads, distance between two successive threads is called the pitch, and that pitch upon the total number of divisions on circular scale. Now this is the circular scale, and there are total number of divisions here that divided by pitch. Now we get the least count. That we see in the observations how to calculate the least count. before that, when we use the instrument, any instrument or measurable instrument, we must have to set that instrument. Either there should not be the error in the instrument. If there is an error, then how it measure, that we will see now. Now zero error is of three types. One is zero error, that is no error. Second one is the positive error, and third one is a negative error. Now when we say that the error, there is no error in the instrument, when we two jaws are nearer or close to each other, and if the zero of the circular is completely coincided with the reference line here, the reference line, if the zero of the circular is completely coincided with the reference line, then we can say that there is no error in the instrument, that is zero error is zero. Now second type is that if the zero error is, when we say that the zero error is positive, now if the zero of the circular scale is go ahead with the reference line or to the reference line, and how many divisions go ahead with the reference line, it means that it goes ahead means with positive error, and the correction of that error is a negative. If suppose that there are 5 divisions go ahead with the reference line, then plus 5 is the zero error. But when we take the total reading of the object, at that time we have to subtract it, these 5 divisions, by multiplying least count, and therefore the correction is a negative. Now if the zero of the circular is below the reference line, then how many divisions it belows, then that count and multiply it by least count, that type of the error is called the negative, and we must have to add this much amount of divisions in the total reading, then we get the correct reading, and that error, or that is called the positive correction. Now in this way there are 3 divisions of the error. One is zero error, another one is a positive error, and third one is a negative error. Now here we take the observations for this instrument. In that, first is determination of least count of the screw gauge. You know the least count. What is least count? Least count is the minimum measurement by a measurable instrument. Now here we have to count, or we have to determine the least count of the micrometer screw gauge. In the observations, the smallest division on main scale. Now here this is a main scale. Now this is a main scale, and here it is in millimeter. Now here in between 0 and 10 there are 10 divisions. It means that the value of one division is a 1 millimeter, or we can say that it is a 0.1 centimeter. Now second observation is that number of full rotations given to the screw, that n is equal to 4. Means what? Suppose if we close these 2 jaws and record the line here, suppose this is the 5th division of the circular, and give the 4 rotations, then suppose I give this 4 rotations. When 0 comes to the reference line, then we say that this is 1 rotation. Second rotation, again 0 comes to here to the reference line, then second rotation, and third rotation, and the fourth rotation when it 0 comes to the reference line. Now in this way there are 4, we give the 4 rotations, and when we give the 4 rotation to this circular scale, at that time distance moved by the screw on the main scale, d is equal to 4 millimeter. It means the 4 lines are open here. It means the distance covered by these 4 rotations is a 4 millimeter, means 0.4 centimeter. Okay, now hence pitch, P is equal to what? Capital D. What is capital D? Capital D is a 4 millimeter. Upon number of rotations, n is equal to 4. Then 4 millimeter upon 4 is equal to 1 millimeter. Now this is the pitch, that is equal to 0.1 centimeter. Now this is the pitch. Just I told you that the definition of the pitch is the distance between the 2 successive or consecutive threads of the screw is called the pitch. Now number of divisions on the circular are here. On a circular scale there are 100 divisions, 0 to 90, and again there are 10 divisions, means total 100 divisions are there. And hence the least count is equal to P by N. What is P? P is the pitch, 0.1, that is 1 millimeter. And total number of divisions on circular, N is equal to 100. Therefore 1 millimeter upon 100 is equal to 0.01 millimeter. It means 0.001 centimeter. This is the least count of the micrometer screw gauge. The meaning of least count of micrometer screw gauge is 0.01 centimeter. It means that we can measure the minimum, or we can measure the measurement. We can take the measurement minimum up to 0.01 centimeter. We can convert it in meter, that is 0.001 into 10 to minus 2 meter. Then we can write it as a 0.01 into 10 to minus 5 meter, that is equal to 10 into 10 to minus 6 meter, that is equal to 10 micrometer. Now here the unit is micrometer. It means that we can measure the minimum measurement by this instrument up to 10 micrometer. Hence it is called the micrometer screw gauge. Now second observation is zero error. What is the zero error in this instrument? We close the two jaws here, fixed jaw and movable jaw to each other, close to each other, and when we see that the reference line and the circular of the zero are not coincided to each other. Now the reference line and zero, the zero is go 5 divisions upward, 5 divisions go ahead, means the error is positive error, means here we have to write the 5 divisions. Okay, and then you multiply it by least count, then 0.01 centimeter, then we get the 0.005 centimeter is the zero error. Now here the correction is negative, means zero error correction means zero error correction is equal to minus 0.005 centimeter. It means we have to reduce this zero error correction from the total reading. Now observation table. First we measure the diameter of the wire. Now this is the wire. Now this wire is fixed in between the two jaws. Put in these two jaws. Fix it in between these two jaws and take the readings here. First we have to take the reading of the main scale. Here one line is open only on the main scale. It means that 1 millimeter is the main scale, or 0.1 centimeter is the main scale reading. Therefore we have to write here 0.1 centimeter is the main scale reading. Then coincident divisions on circular scale. Which number of line is coincided with the reference line here? If we see that the above 50 and 1 or 2 divisions go ahead from 50, that is 52 number line is coincided with the reference line. Then circular scale reading is equal to what? B into least count. What is the B? B is equal to 52 into least count is 0.001. Then it is equal to 0.052. Then observe D0 means what? A plus C. That is called the total reading here. D0 is equal to A plus C. A is equal to what? 0.1 plus this 0.052, and that is equal to 0.152 centimeter is the observed reading. Then what is corrected? We have to reduce, or we have to subtract this zero error correction here. 0.152 minus 0.005, then we get 12 minus 5, that is 741. 0.147 is the corrected reading. Okay, now change the position of the object for the another position here, because if the wire is not uniform, then the reading may be different. again measure the reading here. The main scale reading is again 0.1. Circular scale reading is here 59. Then here multiply it by discount, then we get 0.059. Then observe reading, we get the 0.159. Subtract this zero error correction, then we get 0.154 centimeter. Now this is the second observation. Now for the third observation, again change the position of the wire and fix into the two jaws and take the readings here. Again here the main scale reading is 0.1. Only one division is open on the main scale, therefore 0.1. The main scale reading and the circular scale reading is 60 again here. Then to circular scale reading is equal to 0.060. Then observed reading is 0.1 plus 0.060, that is 0.160. Then corrected reading, subtract this zero error correction, that is 0.155 centimeter. Then there are three readings, that is 0.147, second reading is 0.154, and third reading is 0.155. We have to take the average, therefore take the addition of these three. Take the average of this reading 0.147, 0.154, 0.155. Take the addition of these three, then we get 0.456, and divided by 3. Total number of readings are 3. Therefore divided by 3, then we get 0.152 centimeter is the average diameter of this wire, and therefore right here average diameter of the wire is 0.152 centimeter. Okay. Now here the second object is the glass plate. We have to measure the thickness of the glass plate. Again put this glass plate in between these two jaws and take the measurement here. Main scale reading is one line is open here, and therefore 0.1 centimeter is the main scale. Then circular scale reading is about 10. There are 5 divisions, and therefore 15th division is coincided, and therefore the multiply it by discount, then we get 0.015. Again observed reading is main scale reading plus circular scale reading, that is 0.115. Now corrected reading is 0.110. We have to subtract it. In this way, take the another two readings for the different positions of this glass plate, and these two readings are, one is 0.1, 17, and take these three readings and take the average of these three total readings, then we get 0.111. This is the thickness of the glass plate. Now for the calculations here, mean diameter of the wire. What is the diameter of the wire is? 0.152 centimeter. Then what is radius? Then diameter divided by 2, then we get 0.076 centimeter is the radius of the wire. Then area of cross section is equal to what? A is equal to pi r square. Value of pi is 3.14 into radius is equal to what? 0.076 square. Now make the calculations here, then we get the area of cross section of the wire, and thickness of the glass plate is 0.111 centimeter. This is the thickness of the glass plate. These are the calculations for these observations. Now result, your diameter of the wire is 0.152, area of cross section, that you have to make the calculations of these and write here. Then thickness of the glass plate is 0.111 centimeter. Now these are the results of this experiment. Now precautions that we must have to take when we take the readings or when we use the vernier caliper. First, rotate the screw in one direction to avoid backlash error, and second precaution is do not apply an undue pressure while turning the micrometer screw. Now these precautions we must have to take while measuring the diameter or thickness of the glass plate. Now this is the use of micrometer screw gauge.